Timothy Garnett is the technical director and lead engineer at Panjiva, where he's worked for 8 years. He's been involved in all parts of their product, and in particular with ETL, or extract transform load aspects of their data pipeline, data ingest, cleaning, and loading. And he has an MS in computer science from MIT.
Thank you. This on? Yeah. All right, so we're going to be talking about global trade. Global trade is big. It's got big ships. It's got big networks. It's got big data, or at least relatively big data. And it's got big money. And it's also had a big impact. Over the last, say, 30 years or so, global trade has been probably the biggest driver of economic development and poverty reduction at a global level. Lifting directly and indirectly hundreds of millions, if not over 1 billion people out of abject poverty into lower income or middle income or even upper income status. But global trade is opaque, and opacity has costs. It makes it hard to identify bad actors, and it makes it hard to reward good actors. It leads to a host of ills around counterfeiting, diversion, labor abuse, sanction evasion, tax evasion, and a variety of other issues, smuggling and the like. So what does Panjiva intend to sort of do about this? Panjiva's mission is to bring transparency to the global trade industry, to increase the benefits, to reduce the risks, and to deliver data-driven analysis and tools and answers to the global trade community. Panjiva helps companies do sourcing and lead list generation for commerce. They help people analyze and vet potential partners. They help people manage their supply chains, do market analysis. And for the most part, our customer base consists of a lot of importers, exporters in the sourcing world, as well as logistics companies and to some degree enforcement and compliance organizations. So something that was in the news a couple days ago, so kind of proud about that. But C4ADS, it's a nonprofit, I believe based somewhere in this general area of the country, leveraged Panjiva data along with some other sources to develop a list of Chinese companies that were abetting the North Korean nuclear program. And in particular, they identified a very large company based in northern China, leading to the largest enforcement action to date against the company for supporting the North Korean nuclear program, spearheaded by both Chinese and American authorities. So kind of cool. When we talk about trade data, what are we talking about? For the most part, we're talking about shipment records. These can come in a variety of granularities. In the best case, they're telling us who sent a shipment, who received the shipment, what was in the shipment, logistical details of how the shipment traveled, information potentially about the volume or the weight of the shipment. In lesser cases, they may tell us only one side, who sent it or who received it, or they may tell us only sort of that a given company has done an aggregate amount of a particular product category or things like that. And this information is very spread out. A lot of it's collected by governments. A lot of it is public information. In the US, it's considered public record. But it's split up among a lot of governments and a lot of agencies within different governments. And Panjiva attempts to combine that all together to unlock the value present there. So here's an example of a shipment record looks like. It doesn't look like this when it comes to us. In particular, we have a lot of challenges in sort of the ETL space. It's an area that I've particularly done quite a bit at our company. So if anyone wants to talk more about the challenges of that, feel free to grab me during the next break. But just to kind of summarize, we're dealing with a lot of issues. We're dealing with incorrectly quoted CSV files, and we're dealing with files that get put together by concatenating a lot of fields, and so you have a mixture of character encodings all within the same file. We have fixed width formats, old COBOL formats, fixed width formats where there's inconsistent handling, even within the same file, of fixed widths in terms of bytes or in terms of characters. So is it 10 bytes? Is it 10 characters? Sometimes. And it goes as far as the most Rube Goldberg pipeline I can think of is that for one of the reporting pathways, carriers print out a set of manifests of records, kind of like this, a subset of this, of what's on their vessel, and then they, through whatever mechanism they want, internal, Excel, whatever, they just print it to PDF, whatever format they like. Then they email it with a magic subject line that has all the metadata encoded in it to the government agency. The government agency takes that, converts that into a base 64 XML blob, and then sets it on an SFTP site to us. We take that, extract the PDFs, and then process the PDF, doing a lot of form detection and machine learning to templatize these PDFs and pull the data out. When you talk about the raw data, how much are we talking about? Currently, it's about 1 billion records, shipment records from 14 different governments. Like I said before, most of that is considered public information available through FOIAs or other mechanisms like that. It's currently supporting about a $100 million industry around trade intelligence, of which we're a part. And out of this, we pull 8 to 10 million distinct companies. So with these records, we're trying to extract out company entities and then use these company entities to build a larger picture of what our what the global trade network looks like. We use quite a few different techniques for doing this. Generally, we're working with the name and an address of a company, but we're dealing with many different governments. So we're dealing with the Chinese name of a company, as well as the English name of a company, as well as the Spanish name of a company. A lot of companies will use a completely different name for trade purposes than they use locally. And the addresses can be all over the place. That could be just a country, just a city. It could be a very detailed floor and street address, depending on the data set. So we're trying to pull out a lot of features out of this and feed it to machine learning to determine the connections between these records, and then the clustering on top that determines our sort of company entities that feed into our trade network. For example, interesting feature is you can look at the geolocation of the address. So we've found that while there are a lot of services out there to geolocate addresses for you, a lot of them have a lot of trouble with international addresses, particularly if they're messily or partial or incomplete. And so we actually do this as a two-phase thing. We use a machine learning approach to first guess the country or maybe more specific region of the address, and we feed those in as hints to geocoding services. Now let's get out, for a given exemplar, it gets us, a location or maybe a circle of uncertainty around a city or something like that, and that can feed in as a feature to the machine learning. So here's an example company, Under Armour. We've got over 700 variations of its name and address, some of them fairly pathological. And we collapse all these down into one company, or generally trying to collapse first into a specific location for a company, and then into a second higher tier of sort of all locations of a company. We make both available through our platform because different analyses generally are focusing on one level or the other. And here's the kind of the end result of what it looks like on our system. It's a profile of the company. This ETL versus machine learning aspect brings a lot of trade-offs. Like, how much time do you spend on the ETL aspects of pulling out the data and getting the data very clean, versus how much time do you spend on the machine learning, which may be able to paper over a lot of those problems in the initial extract layer. And maybe a time for another talk, but that's an interesting trade-off that we've played around with quite a bit. Here's another part of the picture. You can see in this company we have data from 3 different governments, the US government, the Colombian government, and the Mexican government, about their activity. And Jason is going to take it over from here, and we're going to zoom out and look at this company and other companies in the sense of the broader global trade network. So, Jason.
Thank you. Yeah, so the sort of the fruit of the kind of large-scale ETL and entity resolution that Tim described is that we get a map of relationships between different entities. So in this, what we have up here right now, this is actually showing you relationships between Under Armour, the company, and the ports that it does trade with. Each trace there is its shipping volume into several different ports. But what I want to talk about for the rest of the talk is relationships between companies, which has some obvious use cases that I'll dig into more. So we can look at the once we found Under Armour, the blue circle in this description, we can then look at its suppliers, its overseas suppliers in orange. So this is the network of companies supplying Under Armour, in the international trade space. And we have the ability to, because the underlying data that drives this graph is so granular, we have the ability to slice it in many different ways to fit different use cases. So for example, the edges in the graph represent flows of shipments, but shipments of lots of different products. So we have since we also are able to extract and classify the products being shipped by these companies to Under Armour, we can filter this graph to only look at suppliers of polyester shirts, or to only look at suppliers in China of polyester shirts, if that's our interest. But we can walk out further. We can look at a somewhat broader network. We can look at Under Armour, its suppliers, and other companies that are also buying from those same suppliers. So I walked out two degrees in the network from the company that we started with, from Under Armour. And this starts to be able to answer some very interesting questions. So you can immediately see patterns that kind of make sense here. So you can see Under Armour. So Under Armour, and you can see other clothing retailers like The Gap, Old Navy and The Gap share several suppliers because they're part of the same corporate family, but interestingly, they also share suppliers with Under Armour. And so this is the sort of questions you can start answering if you're doing, for example, a competitive analysis where I want to know, if I'm a competitor of Under Armour, for example, say I'm Patagonia, and I share the supplier right here with Under Armour, both sourcing from that same company overseas. And I can use this tool to see other suppliers that Under Armour is also using that maybe I don't know about yet. So I can do competitive research of that sort. Also, you could use this kind of a tool to look at concentration of risk in supply chains. You could see if a company is really exclusively relying on one supplier for a critical part of its inputs. That could be relevant. We can take that same network, we can put it on a map as a result of the sort of the geocoding stuff that Tim described, which is its own kind of machine learning stack. This is exactly the same network I had before, just with the companies placed at their location. So using this, you could see is there a heavy geographical concentration of a company's supply chain, again, getting into the risk questions. Or I could ask, again, it's more of a competitive analysis or a strategic thing. I could ask, are there regions of the world or countries that my competitors are exploiting that I should also look into? Now we can keep walking out. For fun, we can go out 5 degrees. So now it's the same thing. The blue dots are all buyers, so they're companies that are importing goods on the shipping records, and the orange are suppliers, so they're exporting. Under Armour there. We see JCPenney, which was one of its 2-hop neighbors that had some overlapping suppliers with Under Armour, both in apparel. But as you walk out, you get broader and broader slice of the industry. You see other retailers like IKEA. You see logistics companies that are carrying goods around for these people. And we can keep going. We can look at the entire network of international trade. And what I've done here to make that at least bit manageable is actually rolled it up to a network of communities. So I've applied community detection algorithms to the entire graph of world trade relationships and identified clusters of companies that have overlapping patterns of trade within the cluster as relative less trade between clusters. So each orange square in this graph is such a community. It's a network. So this is a network of networks. And you can look at the companies that make up each of these communities and kind of see that they fall into a consistent industry. I've just labeled a few of those for you. And so this is kind of cool. I mean, it's as you may or may not expect, it's very complicated, very densely interconnected. There's just trading relationships going on, between all sectors here. But there's also patterns you might expect, like a heavy link between energy and chemical, links within different sectors of the retail space. So you can really track the flows at scale. And I think that this kind of thing is sort of neat. You can get similar representations of kind of macro trade flows from other sources. But where our ability to do this is kind of unique is that we're starting with the ground level granular data. And we're building these nodes, these communities automatically based on the patterns of relationships that are revealed by that data. So while they do fall into recognizable industries, there are some sort of a priori surprises. So for example, this energy community, it's got all the big oil companies like ExxonMobil and Chevron, but if you look into it, it also has big cruise lines, like Princess Cruises. And that makes sense when you step back and think about it, because big cruise lines are huge consumers of energy. So economically, there's a tight interlink there, which could be relevant for use cases. So I think this kind of bottom-up analysis, bottom-up data-driven ontology creation kind of could complement other sort of a priori categorizations of industries and of the relationships between them. Okay, so I showed you a little bit about community detection. Other standard network analysis techniques can be brought to bear on this problem domain. So centrality analysis, if you want to know who is a key component of a trade network. So for example, if you were looking at this network of North Korean companies and Chinese trading companies, for some sort of enforcement action, you could figure out who's kind of most important in that. Alerting to network changes. We have all of these edges in our networks are time dependent. They're flows of shipments over time. We can detect anomalies. I'll show you a little bit more in the next few slides of some examples of that. But you might imagine maybe you're like a small specialty foods importer. You have a great supplier of olive oil in Italy. You'd like to know if all of a sudden, Costco came in and started buying olive oil from that same supplier. We could detect when that happens and send an alert. And all of this, of course, can be done not just for relationships between companies, but also companies in ports, companies in geographic regions, products, any kind of entity that we're mining out of the shipping records. Okay, so that was the sort of global zoom out macro view. Now I want to go the other direction, zoom in, look at networks around individual companies, kind of interesting, and specifically look at the impacts of events over time. So I'm going to look at things where there's an event that impacts one company at one point in time. We can look at that in our data and then see how it rippled out to other companies in that network. And a good source of sort of public data for these sort of point-in-time events that have a strong bearing on trade is sanctions and enforcement actions that specifically that block imports into a country. So for example, there's the U.S. Treasury Office imposed sanctions on a company in Belarus in 2011. The company had ties to the government of Belarus, which were the reasons for the sanction. The result of that was that this company was barred from exporting to the United States. And previous to the sanctions, there was trade with the United States. We were able to find this company in Panjiva's database and see who its US buyers were. It happens to be a supplier of yarn. So we can look at the network around those companies. Here's the sanctioned entity in Belarus. Here is its US importer. It happens to be, there happened to just be one company in the US that was buying from this sanctioned company. And we can look at the broader network around the US importer, and it has another supplier with its own extensive network, not very interesting. And a third supplier which, like the sanctioned one, sort of exclusively has a relationship with this company in the US. So that might be a little bit more interesting. So we can look at what happened at the point in time that the sanctions were imposed. Here is the sanctioned entity shipments to the US importer, stopped with the sanctions, but this additional exporter in Russia happened to pick up its exports right at the same time, and it had no trade to the US at all before that date. And this also happens to be shipments of the same product. So as I mentioned, we can filter all of this by product and see that this is the same type of yarn being traded by both companies. And we can look at it on the map and find that they're actually geographically, close together in the same world region. So that I think is very interesting. Another example comes from FDA inspection warning letters. So again, this is public information. When the FDA conducts an inspection and finds violations, they issue a warning letter to the affected company and may potentially take further action. These letters are publicly available on fda.gov, and they list the name and address of the company. So I was able to pull these in, parse out the name and address, match them to the companies in our database through the same machine learning-driven entity matching that we use to build the companies in the first place, and find interesting examples of companies that were affected by an FDA action. So in this case, this was a Chinese supplier of medical supplies. The inspection revealed some of their products to be contaminated, and it was actually a serious enough violation that they were barred from their products into the United States after this inspection until the problems were resolved. So what I'm showing you here is the shipment volume from the inspected company in China to its top US importers. So, so you can see that when shortly after the inspection, that those shipments dropped off. But now it's interesting to look at its top. Let's look at its top US buyer. Okay, so this is the same thing. This is imports by that top buyer from all of its suppliers, all of its overseas suppliers. So, the sanctioned company is one of the choices here. And what's interesting is that apparently shipments to this buyer just dropped off to zero from all of its suppliers after the inspection. Now, I don't think that really is what happened. It turns out that companies can petition to have their names redacted from shipping records. And that's generally what we see when that happens, is we just see no data for that company. And so most likely that's what happened in this case. Okay, so just backing up then, I think that Tim and I described how we're trying to, these are some examples of how we can kind of bring some more transparency, some more insight into this very opaque world of global trade, where the things being shipped around in big, sealed containers are very, literally opaque, where the data that's generated from them is very, in the raw form it exists when you just get it from a Freedom of Information Act request. It's very opaque, very messy. Where we're cleaning that up at scale and, creating the groundwork for answering important questions about trade. Thank you.